For decades, the digital world has run on a very specific kind of clockwork. APIs serve as the universal handshake between software systems. They operate on a simple, rigid logic. A program requests an exact piece of data, and the API delivers that data back. It is a system built for absolute predictability. This architecture relies on a core assumption. Both the sender and the receiver are deterministic programs. They follow a sequence of strict, hard-coded instructions that never vary. This predictability is the foundation of the modern web, but it creates a specific friction point when we try to connect these rigid systems to the fluid logic of artificial intelligence. Large language models don't follow a preset script. They reason probabilistically, weighing the most likely next step based on the information they have in the moment. An AI agent doesn't just call a single endpoint and stop. It chains tools together, interprets unstructured data, and asks follow-up questions to clarify what's next. When an AI model encounters a standard API, it sees a function without a clear description of what it does. Without context, the model can't know which specific action to trigger or what data to pass through. To bridge this gap, developers spend weeks writing bespoke integration code for every single service. They manually map JSON fields for Gmail, handle auth tokens for Jira, and write complex prompts to teach the model. Progress in AI agents is currently limited by this communication gap. We have been forcing reasoning machines to navigate digital environments using a language designed for rigid scripts. The Model Context Protocol, or MCP, is an open-source standard designed to close this gap. It provides a standardized way for models to discover and interact with external resources automatically. To be clear, MCP does not replace the Internet's existing APIs. The back-end systems that store your data and run your services remain the foundation. Instead, MCP replaces the bespoke middleware layer. The custom wrappers developers previously wrote are replaced by a unified interface. MCP acts as a semantic translator. It converts rigid API data into fluid context, so the model can actually read how to use a tool. This transforms static API endpoints into living, self-describing interfaces that an AI can explore on its own. This works through a simple client-server relationship. First, there is the MCP server, a lightweight process that sits directly alongside a company's database or tool. The server provides a machine-readable schema, describing exactly what its tool can do and require. Then, the MCP client, the AI model, connects as a user, scanning this metadata. Using its own reasoning, the AI chooses the specific pathway to achieve a task without human guidance. This shifts the execution logic. Instead of the logic living in the developer's application code, it moves directly into the model's reasoning layer. The role of the client is shifting. It is no longer just a passive script fetching data. It is an active participant making decisions about how to navigate a system. The early internet was fragmented, with different services requiring different internet protocols to communicate. Standardizing on HTTP is what allowed the web to become interoperable. MCP is attempting that same unification for the AI ecosystem. By building one MCP server for a product, that tool becomes instantly compatible with every model that supports the protocol. A developer builds the interface once, and any AI, regardless of the company that built it, can understand how to use it. This moves the industry away from building fragile custom bridges and towards a shared interoperable ecosystem where tools and models can interact by default. Allowing models to autonomously choose and use tools creates new risks. An agent with direct access to a database could make a high-stakes error, like deleting production files or sending unauthorized emails. This makes the protocol layer itself the primary site for security. Robust permission layers and authentication must be part of the description, defining exactly what an AI is and isn't allowed to do before it ever connects. For developers, this requires a paradigm shift. Their job is moving away from writing the instructions for a task and toward describing the capabilities of a system so the AI can figure out the execution. This protocol is more than a technical upgrade. It's the infrastructure for a world where humans are no longer the only entities navigating digital spaces. The true significance of the Model Context Protocol is the acknowledgement that AI models are becoming first-class users of our software.